Hello everyone, welcome to my channel. So today we are going to do Leetcode's one of the question Palindromic substring, and this we are solving blind 75 question. So under that we are doing this question. So now let us first read this question, then we will check about the constraint, then we'll check out whatever possible solutions are there, then we'll go ahead with the implementation part with possible edge cases for the same, and then at the end we'll check the time complexity and space complexity, and we'll check if we could optimize it further or not as per the constraints which are there. So now let us first read this particular question. So here palindromic substring, given a string S, return the number of palindromic substrings in it. A string is a palindrome when it runs the same backward as forward. A substring is a contiguous sequence of character within the string. So basically here in the first example S equals to ABC. So here 3 is the output. How? The three palindromic strings are A, B and C. So here triple A. Answer is 6. How 6? The single characters A itself, right? And then when we do a double character double A, right? And then the AAA itself. So now if you could recall the previous question which we have done in this series, which was the longest palindromic substring, right? So it is somehow similar to that only, right? There we were required to figure out the longest palindromic substring, but here we are required to figure out the total number of palindromic substrings which are present here. Anyhow, there also we were figuring out that how we can basically figure out the palindromes which are there. Only thing was there we were comparing with the length, that whatever previous length was there, can we have any other length which could be longer than the present one. And here rather than comparing the length, we can just check and keep a counter ready with us that these many substrings we have encountered so far, and we can return that number. That is all which we are required to do here. So anyhow, this particular question is similar to the previous one only, but before going ahead with directly the optimized solution, let us check that what naive solution we can go ahead. So here for checking the all the palindromic substrings which are there in this particular, what we can do is, again we will be going ahead with n square loops, right? And inside that we will be checking for the if it is a palindrome or not. So the first which would be there from I equals to 0 till n, right, which will be that this particular in S A B C D C B A. We will be checking, okay, this particular is the ith pointer, and then we will be required with one more pointer J, which will be starting from I plus 1. This is that J, and it will be going up till n, and it will be checking that okay, that till n we are having this particular, these string means every time we will be checking that we have these particular strings, are these a palindrome or not, that all we will be checking. Inside is palindrome function, so that would be the thing we will be going, and because of this whole will become n cube solution. And as per the constraint which are there, it says that it is up to 1000, right? So this particular, if we do, it will become 10 raised to power 9, and because of that we will be getting a TLE. So that's why we require something which is up to 10 raised to power 6 or less than 10 raised to power 6. So that would be the thing, and for that purpose, the way in our previous question we did expanding around the center, that only we will be doing here. But as per the question, we need to modify that solution. That is all what we are required to do here. If you want to go into details of that particular method, you can check out the previous video. I will link that video in the description also, and even the I button which is there in this particular video. But if you are already following this series, then anyhow you will get to know. So now let us go ahead with the implementation part by using the method expanding around the center. So here, so now the first thing which would be there, which we are required to do is that anyhow first we will be writing whatever our base functions which are there, that is this particular, which is the base function. So we require the counter, right? So for that particular person we will be having this answer variable, and then we are required to go ahead with the loops which are there. So I less than n, and here we can directly have that n equals to s dot length. So that would be the case, and then I plus plus. So basically we are iterating for that particular string which is there. Then we are required to keep the count, right? Earlier we were comparing all the lengths, but here we are required to have the count, and that count could come either from the single character center or from the double character center. So for that particular only, here again we will be required to implement that expand around the center function, and in that we will be passing s, I and I. This is for our single center ones, and now comes the part for the other one, that is the double centers which are there, right? For that purpose also we will be writing using the same function, but here the thing would be that we will be required to go ahead with this I plus 1. So that would be the case here, and then anyhow it will be having all the count of double center, single center, everything would be there in answer, so we don't require to do anything else. So that would be the case. Now comes the part we need to implement this expand around the center function. So we will just take this, and anyhow it will return integer, right? So now we are here with the string s, and then let us take this as int left, the way we took for the previous one, and int right. So now what we will be going ahead with is, in this particular we will be having one counter again, and why we require that counter to return that, yeah, these are there, these strings we were able to figure out which are palindrome. So rather than answer, let us keep it as a counter only, counter equals to 0, and then again the same thing the way we did in our last, and here anyhow we are required to call it again and again. So okay, let us check if by passing by reference works or without reference also works. So we'll check that. So while left is basically greater than equals to 0 and right is basically less than s dot size, and we need to check that if that particular is a palindrome or not. So for that case only we will be going ahead with s of left equals to s of right. That all we will be checking in this particular while loop itself, and if that is the true condition, then we will be going ahead with left minus minus and right plus plus. So because of this we will be easily able to go ahead, and here only we will be incrementing our counter as well, that here we are able to get, right? And then at the end we will be returning our counter. So these were the simple modification which we were required to do in a previous solution which we had done, and it is the same method expanding around the center for the palindrome. And here space complexity and time complexity both are same, n square and order of 1. So let us first run this and check if there are any compilation stuff, means any typos and so on. Yeah, there is compilation issue. Okay, yeah, and rather than answer, fine. Okay, so it got accepted in this. Let us check that if it got submitted or not. Okay, yeah, it got accepted overall for all the test cases. So this was all for this particular question. If you have any doubt, you could comment that down, and please do refer the previous video also for more detailed explanation about this expanding around the center. And I hope you like this video. If you really like this video, so please do share among your friends. And yeah, do like, share and subscribe to my channel for getting more such useful content. So this was all. Thank you.